Welcome to Space Explorer 2024. We've sent robots to Mars where they traverse the rocky red terrain, capturing images and data that have transformed our understanding of the planet. We've sent robots into volcanoes where they withstand extreme heat and pressure to study the inner workings of these fiery giants. Now, we're sending robots into the most challenging terrain of all, our oceans. These autonomous underwater vehicles dive to depths humans can't reach, exploring the mysteries of the deep. Liquid robotics is a new frontier, pushing the boundaries of exploration and technology. These advanced machines navigate the underwater world with precision and adaptability. These robots are changing how we understand and interact with our planet. They collect vital data on ocean currents, temperatures, and marine life, providing insights that were previously out of reach. Imagine a fleet of robots patrolling our coastlines, monitoring for pollution, and ensuring the health of our marine ecosystems. They act as guardians of our oceans, detecting and responding to environmental threats. Imagine robots exploring shipwrecks, mapping the ocean floor, and even studying marine life up close. These underwater explorers bring the hidden wonders of the ocean to the surface, revealing secrets that have been submerged for centuries. This isn't science fiction, it's happening now. The technology is here and it's transforming our approach to ocean exploration. Liquid robotics is revolutionizing our understanding of the planet. These cutting-edge machines are not just tools, they are pioneers, leading us into uncharted waters. These robots are our eyes and ears in a world we can barely access. They serve as our proxies, venturing into the depths to gather information and relay it back to us. And this is just the beginning. As technology advances, the capabilities of these robots will only grow, opening up new possibilities for discovery and conservation in our oceans. To understand liquid robotics, we need to delve into the fascinating world of cyber-physical systems, or CPS. These systems are the backbone of modern technological advancements, seamlessly integrating the digital and physical realms. Cyber-physical systems are essentially the nervous system of our technological world. They consist of interconnected digital networks that communicate with physical devices, creating a cohesive and intelligent system. Think of CPS as the brains behind the brawn. Just like the human brain controls and coordinates our actions, CPS manages and optimizes the performance of various physical systems. They bridge the digital world with the physical world, creating a seamless interaction between the two. This integration allows for real-time data processing and decision-making, enhancing efficiency and functionality. Imagine a network of sensors, computers, and robots, all working together in perfect harmony. These components communicate and collaborate, forming a sophisticated and responsive system. That's a CPS in action. It's a dynamic and adaptive system that can respond to changes in its environment, making it incredibly versatile and powerful. In liquid robotics, the physical part is the robot itself, navigating the ocean depths. These robots are designed to withstand harsh underwater conditions and perform complex tasks. The cyber part is the software, the algorithms, the data analysis. This is where the intelligence of the system resides, enabling the robot to process information and make informed decisions. It's the intelligence that allows the robot to make decisions, adapt to its environment, and send back valuable information. This capability is crucial for tasks such as mapping the ocean floor or monitoring marine life. Liquid robotics is a perfect example of CPS in action. It showcases the incredible potential of integrating digital intelligence with physical capabilities. It's a beautiful dance between the physical and the digital, pushing the boundaries of both. This harmonious interaction not only advances technology, but also opens up new possibilities for exploration and innovation. What makes these robots tick? How do they navigate the complex environments they are designed to explore? It's a combination of cutting-edge technologies, advanced sensors, autonomous navigation, and robust communication systems. These elements work in harmony to create a seamless operation. Sensors are the robot's eyes and ears. They are crucial for gathering real-time data. They collect data about the environment, temperature, pressure, salinity, and other critical parameters, even the presence of specific chemicals. This information is vital for understanding the surroundings and making informed decisions. This data is then processed by the robot's onboard computer. Autonomy is key. The robot must interpret this data accurately and swiftly. These robots need to operate independently, navigating through challenging terrains and avoiding obstacles without human intervention, making decisions on the fly based on the data they collect. This requires a high level of artificial intelligence and machine learning capabilities. This requires sophisticated algorithms and machine learning. These algorithms enable the robot to learn from its environment and improve its performance over time. Finally, communication is crucial. These robots need to send their data back to us, ensuring that the information they gather is accessible for analysis and decision-making, whether it's to a research vessel or a land-based lab. This data transfer must be reliable and efficient. This requires reliable underwater communication systems. These systems ensure that the data is transmitted accurately, even in the challenging underwater environment. Section 4. Applications, from ocean depths to healthcare. The applications of liquid robotics are vast and varied. They're already making waves in fields like oceanography, environmental science, and even healthcare. Oceanographers are using these robots to map the ocean floor in unprecedented detail. They're also studying ocean currents, underwater volcanoes, and the impacts of climate change. Environmental scientists are using liquid robots to monitor pollution levels, track oil spills, and study marine life in its natural habitat. Believe it or not, liquid robotics is even being used in healthcare. Researchers are developing tiny robots that can navigate the human body, delivering drugs or performing minimally invasive surgeries. Section 5. Future Forward, the next wave of liquid robotics. The future of liquid robotics is brimming with possibilities. As the technology continues to evolve, we can expect even more innovative applications. Imagine robots working together in swarms, coordinating their efforts to tackle complex tasks. Imagine robots powered by renewable energy, patrolling our oceans indefinitely. We could see robots exploring the deepest trenches of the ocean, unlocking secrets hidden for millennia. We could see robots repairing underwater infrastructure, inspecting pipelines, or even building underwater habitats. The possibilities are as vast as the ocean itself. Section 6. Challenges and opportunities navigating uncharted waters. Of course, liquid robotics isn't without its challenges. The ocean is a harsh and unpredictable environment. Corrosion pressure and biofouling are just a few of the obstacles that these robots need to overcome. Developing robust and reliable robots that can withstand these conditions is a constant challenge. Then there's the issue of power. How do you keep these robots running for extended periods in the deep sea? But with every challenge comes an opportunity. Overcoming these obstacles will lead to new discoveries, new technologies, and a deeper understanding of our planet. Section 7. Conclusion, a sea of possibilities. Liquid robotics is more than just cool technology. It's a testament to human ingenuity, our drive to explore the unknown, and our desire to protect our planet. These robots are our eyes and ears in a world we can barely fathom. They're helping us understand the ocean's mysteries, address environmental challenges, and even improve human health. As we venture further into the 21st century, one thing is clear. The future is liquid,